Hello viewers, welcome back to the Moose Mobile Auto Repair channel, and today I'm going to be showing you on how I hook up a lab scope. I recently got a cheap lab scope. It's a standalone system, so I'm just gonna show you a few things and just go from there. Now, my test vehicle here is a 2009 Pontiac Vibe, and this one is equipped with a 2.4 liter engine. It's the same engine that you would find in the Toyota Camry, Highlander, and the Matrix, and so forth. This is the 2AZ FE engine, so it would be pretty much the same for checking the waveforms if you wanted to compare with a known good to this one here. I know I'm just doing a quick session here, so I don't want anybody to be rambling in the comments and blah 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 and whatever. I'm just showing you on what I'm doing for the time being. So I have the car running now. I have the scope hooked up to the crank and cam sensors. The engine is idling right now. The crank sensor is connected here, and the cam sensor is connected on the side here. I have some engine noise going on over there in the accessory drive area. I'm just messing around, just testing out some new equipment here. Now on scopes, or on the probes, you'll see that it's grounded to here. So you don't have to ground it, but it's better if you do, because it'll give you a better signal, and it will eliminate any unwanted noise or interference that may be in the signal. So when you ground it, it will eliminate noise. This scope is an entry-level scope, so it's not your advanced type of scope, but this should be more than enough for the time being for beginners and for people who don't use a scope that often. So I'm going to run it now, and you can see the waveforms here. The yellow one is the crankshaft position sensor, and the turquoise blue one is the camshaft position sensor. This is a known good waveform, so I'm not having any issues. I'm testing out the equipment here. I just lost the signal for the crank. There we go. It just got unhooked. I hooked it back up again. So I'm just gonna use this, and I'm going to compare it with another known good, just for the sake of comparison. I'm testing things out here on this scope. So I don't use a scope very often, but I'm trying to improve my skills and get better at at what I do. So anyhow, I'm just gonna compare the waveforms here with one available on the internet. So I'm just going to shut the engine off. So I know some people have stated a lot of times, for some of those people who are just trying to learn and get into the into scoping. Even I was having a hard time trying to figure everything out. So it's not that easy in the beginning, but you need to mess around with it in order to get better. So over here I have the red probe here. I used different colors. So this one is connected to the red wire. So I connected the red wire to the probe, and it's going to the back of the oscilloscope here for channel 1. And then I have channel 2. This one is for the crank sensor, and the channel 2 I put it for the cam sensor. Channel 2, just about the same. I hooked it up to in the back here. I hooked it up in the back here to the red wire. This is a 2-wire sensor. 2 wire for the cam and 2 wires for the crank. So anyhow, the way I set up my scope here, channel 1, I set it up, channel 1 for the crank, I set it up to 500 millivolts per division. It's set on AC. It said probe mode 1x, 10x, 100x. Because the probes, I believe this one is rated for up to 30 volts. So I went to 1 because this is the lowest setting. These sensors don't put out any more than like a 5-volt reference for the crank and the cam. So yeah, so the channel is on, coupling AC. I'm looking for the this produces an alternating current signal, AC current. That's for channel 1. Channel 2 is 100 millivolts per division. Very similar to channel 1. And I set the trigger to auto. The trigger is on the rising edge for channel 1 and 2. So the main issue I had here with this scope is that I wasn't able to get any waveforms on the screen. And so I found out that I have to lower the millivolts per division. And I also have to lower this part here for the trigger. This one is set at 5 milliseconds per division. It was set too high. So I reduced it, then I was able to see a signal after. At first, I disabled the fuel system so that the engine will not start, and I cranked it over so I would be able to see the signal. So what I learned about this, because I don't use a scope very often, right? So what I learned is that I saw here that the trigger was set at 50%. So what that means is that when the scope receives a signal, so say if it receives like 200 millivolts, which is 0.2 volts. So it will show the signal once it reaches 100 millivolts or 0.1 volt, and then it'll start showing it here. So if you have the settings set up incorrectly, you will not be able to see a waveform here. So you gotta make sure and watch on what the trigger is set at. So this basically, it triggers the scope to show the waveform if it's within 50% of on whatever the reading it receives. So I hope that may help some people out, because that was the main issue on what I was trying to figure out. I really had a hard time. And I also have the Picoscope 6. I've used it in the past, but I just didn't like I didn't like bringing out the laptop and stuff, and then the laptop that I have is very old and slow, so I didn't like the idea of bringing the laptop out and stuff. I like this one more because it's a standalone system device. So I don't have to bring the laptop out, and it's nice and handy, and I'm able to save the waveforms and go through the waveforms for future reference. I can go to waveform view. I can go to all of the saved waveforms. Return. And then there's the picture view. This when I save the screenshot of the waveform. This is what I really like about this device here. I'm not gonna say it's better than the Picoscope, but it really depends on your application. The Picoscope has more power and has more ability to do more things with the waveforms. This one is just your basic scope, but for someone like me, it should be more than enough for the time being. So the battery is fully charged. I disabled the fuel system. I'm just going to crank it over just to show you guys on the waveforms. So I'm going to run it. I'll have to do it again because I gotta make sure I stop it as soon as I'm no longer cranking the engine over. So we are going to run it. Now the issue here is when you have the engine idling, you're able to get a better view of the waveforms than when the engine is just cranking over, because the starter can crank over the engine ever so much in comparison to when the engine is actually running, because it's running at a higher RPM, so you're able to see the waveforms a lot better. Sometimes, in some instances, there's no way to analyze the waveform unless you have a known good, and so you can compare the known good side to side to the vehicle that you are working on, and then you can compare and see on what's wrong within the waveforms, and conduct your analysis then to see on what the issue is. I was actually not planning to make this video. I know I don't have my actual uniform on, but I decided to shoot the video anyways. I was just really trying to tinker around with this scope. It's pretty neat. But if you guys have any comments, or if you want me to show you a little bit more on how to use the scope, please leave a comment below, and let me know on what you guys want me to do. I hope you found this video helpful. If you did, please don't forget to give it a like, and please consider subscribing to my channel if you're not already a subscriber, and I'll see you guys next time. Have a good day and take care.